In this video, we will look at series and parallel circuits. Let's start off with series circuits. Here is an example of a circuit in series. There is a 5.0 voltage battery as power source. A stands for ammeter, R1 and R2 are resistors, with V1 and V2 as voltmeters. We can note the following about series circuits. All components are in a single loop, bar the voltmeters that need to be placed in parallel. The current I is the same at all points as it flows around the circuit. The potential difference drops as the current flows around the circuit, and the total measured by the voltmeters is equal to the supply potential difference. We are now going to work out the current I and potential difference measured by voltmeters V1 and V2 for this circuit. Let's start off with the current. From the equation V equals IR, and knowing that the current in a series circuit is the same at all points, we can state the rearranged equation as I equals V over RT, where RT is total resistance of the circuit, and we know V equals 5 volts. In a series circuit, RT equals R1 plus R2, and so RT equals 10 ohms plus 10 ohms equals 20 ohms. So the current I flowing around the circuit would be 5 divided by 20, which is 0.25 amperes or amps. Now let's work out the potential difference across voltmeter V1. We will use V equals IR, which becomes V1 equals I times R1. We already worked out I, the current, to be 0.25 amps. So V1 equals 0.25 times 10, which is 2.5 volts. V2 will also be 0.25 volts, as R2 has same resistance as R1. Finally, we can check that V1 plus V2 equals 5.0 volts, which is the same potential difference as the power source. Now let's move on to parallel circuits. Shown here is an example of a parallel circuit. We can state the following about parallel circuits. There is more than one loop in the circuit with resistors in separate loops. The total current IT splits into I1 and I2 when the circuit splits into 4 resistors R1 and resistor R2. The potential difference PD is the same as the source PD across both loops or paths in the circuit. Now let's work out currents IT, I1 and I2. Current IT, which is total current in the circuit, from V equals IR, where R equals total resistance of the circuit RT, we can rewrite V equals IT RT. For a parallel circuit, in order to work at the total resistance, 1 over RT equals 1 over R1 plus 1 over R2, which is 1 over 10 plus 1 over 5.0, which gives us 3 over 10. So RT in this case will be 10 divided by 3, which is 3.3 ohms. Now we can work out IT as it is V over RT. When you plug in the values, it is 3.6 amps or amperes. Finally, we can work out the currents I1 and I2. I1 is V over R1, which is equal to 12 over 10, and that gives us 1.2 amps. I2 is V over R2, which is equal to 12 divided by 5, and that gives us 2.5 amps or amperes. Finally, we can check that I1 and I2 is equal to 3.6 amps, which is a total current flowing around the circuit. Thank you very much for watching this video.